Hi there. In today's video, we are looking at question 11, which is a probability exam question taken from the November 2024 Paper 1 Grade 12 exam. Okay, let's get into it. So here we are told that a certain number of learners are sitting for examinations in mathematics, tourism, and geography. All these learners sit for at least one of these exams, and then we are given the totals for each subject. So this is the total. Okay, that's too big. Let's make it slightly smaller. These are the totals for maths, tourism, and geography. And then we are told 5 learners sit for maths and tourism, but not geography. And then 4 for maths and geography, but not tourism. 3 for tourism and geography, but not maths. And then 6 only sit for tourism. So these are our key values. Then we asked in 11.1 to draw a Venn diagram to represent all the learners sitting for these examinations. Okay, so in our Venn diagram, we need to show that in our sample space, there are intersections. So let's draw our Venn diagram. I think this is big enough. Okay, let's draw our circles that represent each subject. So starting with maths. Okay, that's too big. Let's maybe do that. Why is it disappearing? Okay, there we go. No, I don't like that. Yeah, my circles are uneven, but we're going to look past that. Okay, this one is very off. There we go. I think that's better. So these are 3 circles for each subject. So we can label this to be maths. This can be tourism, and this can be geography. So now let's go back. We know the totals, but we can't start with the totals. So let's start with the ones that have intersections. So the first one is 6 learners sit for tourism only. That's easy, so we can just put that there. And then that's out. And then next is the learners that sit for maths and tourism, but not geography. And that's 5. So maths and tourism would be, let me highlight it in this region, but not geographies. And that's where that 5 goes. Then 4 sit for maths and geography, but not tourism. So let's pick a different color, maybe orange. So it's maths and geography. We're looking at this part of our circle, our intersections, and that number is 4. And then next is 3 that sit for tourism and geography, but not mathematics. So this would be the intersection for tourism and geography, but not mathematics, and it's 3. Okay, so we have used up all of those. Nice. Now let's move on to the totals for each section. Let's see. So firstly, which one has the most information that we can deal with? We can start with tourism because that's the circle with the most information. We've got the 5, 3, and the 6. The only value that's missing is the number of students who do all 3 subjects, which is right there in the center. So we can calculate that using the total for tourism, because we know that the total for tourism is 16. So to calculate the remaining, it would be 16 minus the 5, the 6, and the 3. 5 plus 6, that's 11, plus 3, that's 14. So now we're left with 2. So it means that here there are 2 students who write all 3 subjects. Okay, so now we can do the calculations for maths and also geography. Let's start with maths. So we know there's a total of 22 students that do maths. So we want the number of students who only do maths without the other 2. So that will therefore be us taking 22 and subtracting all the other intersections. So minus 5. And then we're going to add the 2 and the 4. Five plus 2 is 7, plus 4 is 11. 22 minus 11 is 11. So here we have 11 students who only do maths. And then lastly would be the number of students that do geography. So it's the same. We know the total is 18. So 18, and then we subtract the intersections. That would be 4 plus 2 plus 3 is equal to. So 2 plus 3 is 5, plus 4 is 9. 18 minus 9 also gives you 9. So here we are left with 9 students who do geography only. And that is our entire sample space, because we were told that all the learners in the sample space have to fall into one of the circles which represent each subject. So that means we are done with 11.1. Moving on to 11.2. So this was 11.1. Calculate the probability that a learner chosen at random will sit for examinations in at least 2 of the subjects. And the key word is at least. So that means we can include the intersection over there that has all 3 subjects where there are 2 learners. So therefore, we want the probability of at least 2 subjects. And this will be equal to, so that will be all the students that are in the intersections that are 5, 4, 2, and 3. And then we're going to divide by the total number of students that are writing these exams. And the total, we can get it by adding all the subjects. So that will be 11 plus 5 plus 2 plus 4 plus 9. Haven't added the 3. And then I think the only number that's left is the 6 for tourism. And here this then simplifies to, at the top, you've got 14. And at the bottom, calculating all of that, you end up with 40. And then this simplifies to 7 over 20. And Converting to decimals, that would be 0.35. And this is our solution. For the number of students who write at least 2 subjects. Okay, lastly, moving on to 11.3. So the question asked, determine if the events sitting for examinations in mathematics and sitting for examinations in tourism are independent. Support your answer with the necessary calculations. Okay, so for 2 events to be independent, they need to meet this condition. So independent events must, if I take event A, multiply it by event B, this should be equal to probability of getting event A and B, meaning each individual event should be equal to the intersection. All right. Well, if I multiply the independent events, it should equal to the intersection. Okay, so let's now do this calculation for our scenario. So for us, we are looking at the probability of a student writing mathematics multiplied by the student writing tourism. And let's solve for that. So this will be equal to, so let's first calculate the probability of a student writing mathematics. For that, we just use the total, which is 22. So it would be 22 divided by the total number of students, which is 40. And then we multiplied by the probability of tourism, and that value was 16. So it would be 16 over the total number, which is 40. And simplifying this, you get an answer of 11 over 50, which when we convert to decimals is 0.22. That's the first answer for this part. Now, we need to then calculate the probability of a student writing maths and tourism. So that would be probability of maths and tourism. And that will be equal to, so based on our circle Venn diagram here, we can see that would be maths and tourism. That intersection has this 5 and 2. That would be 5 plus 2 over 40, which simplifies to just 7 over 40. And converting that to decimals, we get 0.175 as our answer. Let's highlight that with a different color. We can use this teal. Okay, so now we've calculated each value individually, and we can see that these 2 values are not equal. So if they're not equal, it means they are not independent. So therefore, probability of a student writing maths multiplied by the probability of a student writing tourism is not equal to the probability of a student writing maths and tourism. And putting this in words, it means that events M and T are not independent. Oh, not a typo. Independent. There we go. And that's it for question number 11.